Good morning, everyone. This is a video I put together, just a quick explanation of some of the terms you're going to need to finish the rest of this forces unit. So you'll remember that the force of friction is a force that opposes your motion. Whichever way you're going, it's always the opposite. The normal force is the force to the surface but applies to an object. I'm going to explain that a little more in a little diagram in a second. It always acts perpendicular to the surface, and we can use the F net in the y direction to find those values. So picture an object on a surface, and let's see if I can make it move. So this would be my object, right? So as the object moves, friction is opposing the object in the whichever direction you're going. If I were to look at it, we know that gravity always acts downward on it. So gravity is acting downward, and to counteract that, the surface applies a force upward on the box. And you can put the arrows in the other direction, but you have to be, the direction they're pointing is important, not where they're at. And so the normal force is upward. And if I do the F net equation for this, F net in the y direction, so y just like in math, is all the forces up in the positive direction minus all the forces down in the negative direction. We know that this isn't moving in these kind of scenarios, so this is going to be 0. Since this is 0, then we know the normal force is going to equal the force of gravity. This is only true if you're on a horizontal surface. If I took the surface, if I can move that, if I took the surface like this, and I tilt that, then this is what would happen. Force of gravity is still downward, but then the normal force would actually act perpendicular to that, and then they're not equal anymore. So for what we're doing, we're only going to look at the horizontal surfaces. So these type of situations. So for us in grade 11, this is true. In grade 12, we'll take the variation of this, and we'll deal with what happens if the surface is at an angle, or if there's applied forces and that stuff that are at an angle. But for now, this is our key right here. Another thing we need to talk about is the coefficient of friction. The coefficient of friction is just simply a ratio of the amount of friction to the amount of normal force you have. So the more friction you have compared to the normal force, the greater the coefficient of friction. Think of it as if you're rubbing your hands together. Right? When you rub your hands together, there's friction. If you push upward with your bottom hand, increasing that normal force, right, you're going to increase the force of friction. But the coefficient of friction is only based upon the surfaces that are acting together. So it doesn't matter if your hands are, if you apply more force, there's going to be more friction. But the coefficient of friction, that ratio won't change. If I put my hand on a desk, right, then my surfaces are different. So when I move it on a desk, it's a different amount of friction for the force. If I take a block and put it on the floor, if I take a block and put it on concrete, I put it on asphalt, whatever the case may be, they'll all have different amount of friction. The normal force in that case, because the same block and all the surfaces should be the same, right? Because the normal force can equal the force of gravity. But the amount of friction will vary. And of course, you've experienced this, just thinking of walking. If you're sliding, if you slide differently than you do on gravel, than you do on asphalt, than you do on ice. Your normal force will still always be the same because you're still your same weight, but they have different surfaces. So the coefficient of friction is that ratio to the amount of friction you feel, or the object feels, to the amount of normal force. So to put it in a formula, mu, which is the symbol for coefficient of friction, which looks the same as micro, which we did at the very beginning, months ago. So coefficient of friction is equal to the force of friction divided by the normal force. We don't really work in this format because we're usually wanting to know the force of friction. So we're going to use this formula. Force of friction equals mu times the normal force. Same thing, just rearranged. But this is our formula, our key formula. So given those two things, and you can find a multitude of coefficient of frictions. There's some in the table that's in your notes on the page that we're supposed to start on. Right? You can look up coefficients of friction. You can find coefficient of friction. We'll do a modified version of a coefficient of friction lab. Normally what we do for coefficient of friction lab is, well, the last time we did it, I took a sneaker, and you had to pull your sneaker across the lab table, and you added weight to it. And as you added weight to it, you changed your normal force. But the surfaces didn't change any. So the force of friction would increase because we have more force now, or we're pulling more. But the coefficient of friction, if we work backwards using this right here, should stay constant. So when we do the lab, the goal is to determine whether this value stays constant. We'll do a version of it. I'm going to make a video. I'll get my lab assistants here at my house to help me. I'll do a video. I'll post a video. The lab's there. I'll give you some pointers. I'm going to do an Excel how-to video so you can do the work on it. And we'll do this kind of a modified lab. If you have the stuff at home, then maybe you can actually do the lab at home. I can show you some tricks to maybe get around it. So let's put this all together. This is what we're going to need in order to figure out the rest of these questions. This is our first formula way back, or our first scenario. The net force is equal to all the forces pointing in the positive direction, so it's not where they are, it's where they're pointing, minus all the ones in the negative direction. And this is our F net equation, and it's always based upon the free body diagram. And I'll give you some free body diagram practice stuff later. But it's always forces in the positive minus forces in the negative, and they have to match the free body diagram you've created. You remember F net equals mass times acceleration. Also, the force of friction equals mu times Fn, which we just talked about. Force of gravity equals mass times gravity, which you should have looked at, or we'll look at after this. And the normal force equals the force of gravity. And remember, this is not a formula, but it's based upon the free body diagram, and it's only true for object on a horizontal surface moving left or right. So these four formulas are going to tie together. I'm going to do another example after this and show you how these all tie together to solve any one of these problems that we're moving horizontally. All right, thanks. I'll see you in the next video.